My YouTube channel. Today I'm solving Leetcode question 472, concatenated words. So this one is kind of very similar to the word break 2. So I have a video about how to solve the Leetcode question word break 2. So if you haven't seen that video, I recommend to solve that problem first before moving to this concatenated words problem. So given an array of strings words without duplicates, return all the concatenated words in the given list of words. A concatenated word is defined as a string that is comprised entirely of at least two shorter words in the given array. In the example 1, this is the input words, and then the output is cats, dog, cats. So this cats, dog, cats is from the list words, so you can find it originally here. And then it comprised of at least two shorter words in this words. So it can be broken down by cats, dog. So it's cats, dog, cats. And then the second element in the output is dog, cats, dog. So that's kind of also from the original words list. So we find the dog, cats, dog, and it can break down to dog and cats. And similarly, the rat, cat, dog, cat. So that is from the original word list, and then it can be break down to rat. Rat is in the original words. Cat is in the original word. Dog is in the original word. Cat is also in the original word. So for the example 2, words is cat, dog. So in that case, the concatenated word is cat, dog because it's comprised of cat and dog. So when you take a look at this problem, you will find, okay, it's very similar. Let's say, basically it's to find, okay, if any words in this words list can be break down to at least two or at least two shorter words. So that's kind of very similar to the word break 2. So how to solve this one? So the idea is, let's say we can try to check for each word in this words list. We can try to check, okay, by check every position. So let's say here for C, is C a word in this words list? No, C is not. And then to check CA, no, CA is not. And then CAT, and then CAT, yeah, CAT is itself, but then the thing is there's nothing left after CAT. So, but here in this example, so we can check, okay, if we, let's say, place a partition around here, let's say we break it down to cats and then dog, cats. So it is cats in this words, yeah, cats in this words. So dog, cats, is dog, cats in this words list? No, it's not. But can this dog, cats be break down to at least two shorter words? So which means, is this dog, cats a concatenated word? It is. So in this case, this cats, dog, cats is a concatenated word. So basically the overall idea is actually we're trying to place a partition to break down the words. Okay, if we place the partition here, we break it down to C, A, T, S, D, O, G, C, A, T, S. And in that case, it doesn't work because C is not a valid word in this word. So we are trying to check, basically trying to place this break between the characters to see if we can break them down. So that's kind of the overall idea for solving this problem. So let's code the helper function. So helper. So basically in the helper function, let's try to check if this word is a concatenated word. So basically by checking that, we just try different breakdown. If the word I in this, before doing that, let's try to convert the words into a set. Why am I converting this words list to a set? Because I want to check, let's say, if this word is this substring word up from position 0 to position I minus 1, if it is in this words. So if I convert this words to a set, the time complexity would be O1. If I keep it as a list, the worst case complexity can be On. So that's the reason why I'm converting this one into a set. If it is in the words, then we also want to break down the rest part. So basically, the rest part is starting from I substring. This one either in words, or we can actually break down this one into a word. So if that's the case, we just return true. Else, we just return false. So what does this mean? So remember, concatenated words is comprised of at least 2 shorter words. So that's why I'm not only looking at the substring up until the position I minus 1. I'm also looking at the rest part, if that's a valid word in these words, or if we can further break this down. If we can, then in that case, we find a concatenated word. So in that case, it means return true, means that, okay, this word is a concatenated word. Or if we check all the possible options, let's say after we finish looping I, we still cannot find the a valid word. In that case, we just return false, which means this word is not a concatenated word. And then we are actually checking this one for every word. So let's for word in words, just if helper word, then we just append to the result. And then in the end, we return the results. Okay, and then I run the test case. Okay, so it passed the test case. Let me try to submit it. Yeah, so this is the solution. The overall idea for solving this one is pretty much simple. So basically, we just check for every word in this words list. We just want to check if this word is a concatenated word. If it is a concatenated word, we add it to the result. And then we use a helper function to check if this word is a concatenated word. In this helper function, we just loop through every possible partition. So basically, we are trying to break this word at different position. Let's say we break for this I, after we place this partition, we break the words to at least 2 parts. So in the first part, word up until from the position index 0 to position index r-1, if it's in words, and then we check the second half. If the second half is in words, in that case, this is a concatenated word. If the second half is not in the word, it's like the scenario. Let's say we will find the breakdown here. If we in this example, if we place the partition here, so cats is in the words, but dog cats is not in the words. But we can further break down because dog cats itself is a concatenated word. So that's kind of the part we call it. We call the helper function for this word. If that's the case, we just return true, which means, okay, we find the concatenated word. If not, let's say after we try all the possible breakdowns for this word, we still cannot find one valid breakdown. In that case, we just return false. So that's kind of the overall idea for solving this problem.